Hi everybody, today we are going to do some work on area. So a little bit of an introduction to it, and the things that we are going to cover are we're going to cover what does area mean? How do we measure the area of a shape? What will we use to measure that area? We'll work through some examples and I'll give you my favourite top tip for remembering how to calculate the area and how to write it down. Okay, let's get stuck into it. So the first question that I want to ask and answer, hopefully, what does the area of something actually mean? I've written down here that area is another way of describing how much space that is covered. And that's right, if you think of any shape, if you think of the outline of your house, if you think of the outline of your hand, if you were to put it on the table, if you've got a jotter next to it, if you look at that jotter on the table, if you look at where you might be sitting right now, if you look at, it could be a chair, it could be a box, it could be anything. It's how much space in the world that object or item takes up. So if you were to lie on the ground and we were to draw a line around you in white chalk and then you were to stand up, we would have drawn an outline of you, and the area on the floor that you took up would be inside the chalk line. So the example that I've given you here is the area of the football pitch at Mearns is the amount of space that football pitch takes up in the ground. That basically means everything that is green is space, so that's the area of the football pitch. I hope that makes sense, guys. So it's the amount of space that something takes up. It could be tiles on a wall, it could be a carpet on a floor, it could be anything at all. So let's try and figure out how we measure the area of a shape. Let's try and work on something a little bit smaller than the football pitch because it's a little bit large. Let's start with something like this nice, beautiful yellow square that I've drawn. Okay, that's not too big, that's a manageable size. Now, to measure the area of something, what we do is we break it down into smaller squares. So we need to break this square down. So this square here, it's a decent size, it's quite small, but let's break it up just a little bit more. Okay, what size will we break it into? Well, let's remember our square facts first. The good thing about a square is all the sides are the same length, okay? They're always the same length. So this square here, I've just measured it. It's 5 centimetres by 5 centimetres by 5 centimetres by 5 centimetres, okay? But let's break it up into smaller squares. And what I'm suggesting we do this morning is we break it up into squares that are just 1 centimetre long on each side. Okay, so it's 1 centimetre by 1 centimetre by 1 centimetre by 1 centimetre. So that is what I would call a 1 centimetre square. Makes sense, doesn't it? It's 1 centimetre long on each side, so it's 1 centimetre square. Now, how many of these will fit into that square? Now, you may be forgiven to thinking, well, if that's a 5 centimetre square and that's a 1 centimetre square, we'd probably fit 5 in there. That would kind of make sense if you think about it, but if I look at that and I think I could get much more than 5 in there. So let's take these little squares and see how many we can fit in there. Let's try that now. Okay, so I've drawn out the big yellow square a lot of times, okay? And here I've put one of the little 1 centimetre squares in. Then I've put a second one in. And now I've put a third one in. And now I've put a fourth one in, and I get all the way down here and I've put 5 in already. So all along there are 5 1 centimetre squares along the bottom. Remember it was 5 centimetres long as well, so that would make sense. Let's put a 6th one in so we start a new line, but this is going to take a bit of time, so let's add some more. So then I've added some more, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 1 centimetre squares in. And it kind of looks about half full now. Let's add a few more. Now I've got up to 19 in it, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's fill it up. So I've managed to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We can fit 25 of those 1 centimetre squares inside the big yellow square. That means that the area is 25 squares. It would be 25 squares it would fit in. The other thing that I'm noticing here is every single line has got 5 of those centimetre squares in it. That's an interesting thing to notice as well, isn't it? Let's see what we can do next. Right, so we looked at this square. We wanted to figure out the area of this square, so we filled it up with 25 squares that were 1 centimetre long. And we called that a square centimetre. So therefore the area of this big shape, they're exactly the same size, is 25 square centimetres. And then when we were writing area, we've got a little bit of a cheat way to do it so that we don't always have to write square centimetres. We write square centimetres as cm like we normally do for centimetres, and we put a little 2 up in the top corner. That just shows everybody else that it's area that we're talking about. So it's not distance that we're talking about. We're talking about the area, the amount of space that's filled up inside the lines, okay? So it's not how long a line is or how long each side is, it's how much space, okay? And the area we show by using the little 2 number, okay? We need to remember that for the future. So remember that little 2, but it'd be good to remember some other things as well. So let's see what we can do next. We will work on a few examples. I've put together a few samples here, just some different types of shape, okay? So this one here is a rectangle, and it's 3 centimetres long. So I've managed to get 1, 2, 3, 4, 5, 6 centimetre squares in there. So that has an area of 6 square centimetres, which we write 6 cm and then the little 2. If we come over here to the right hand side, it's just a line and it's only 1 centimetre wide, but it's got 1, 2, 3, 4, 5, 6, 7 square centimetres in there. So its area is 7 square centimetres, and remember we write the cm2. Come over here to this shape, it's a bit long, it's a long rectangle this time, and we've managed to get 10 of the centimetre squares in there. So the area of that is 10 centimetres squared. Now we get some different types of shape, okay? These are not just rectangles and squares, although they kind of are made of rectangles and squares. If you look down there, that's a big rectangle, and that's also a rectangle, and that's a rectangle, and that's a rectangle, and that's a little rectangle in the middle. So this one over here looks like it's a big T shape that's fallen on its side, and I have managed to get altogether 20 of the square centimetres in there, so it has an area of 20 square centimetres. And the big one down the bottom, the big capital H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 square centimetres. So this one here is the biggest area, and this one has the smallest area. And that kind of makes sense really, because that seems to be, just by looking at them, the biggest shape, doesn't it? Okay, let's think about how we are now going to remember the area of a shape, how we are going to remember what that is. Right, it's top tip time, guys. This is my top tip for remembering how to think about the area of a shape, okay? The way that I remember it is that we use squares to measure area. Now I remember this by putting, which is meant to say putting, so I've noticed my spelling mistake. We put the word squares and area into a new word. So I take squares and I take area and I put them in a couple of cars and I smash them together. And squaw is all that remains of square, and rea is all that remains of area. And they smash together into a new word, and it's squarea. The squarea of a shape. That's what helps me remember that we measure area in squares. It is the squarea. That's just the way I do it. If that's helpful for you, use it. If it's not helpful for you, forget you ever saw this. Okay, let's go on to the next slide, because we've done rectangles and we've done squares and we've done big shapes that look like they're a mixture of rectangles and squares. But what about other shapes? So the big question is, does this thing that we are doing just now, does it work for any shape? Well, it works great for shapes that have straight sides, especially squares and rectangles, or shapes that you can fit a square nicely into. So it works nicely for this, we'd give that a big tick. We give the rectangle a big tick. We'll give this shape down here a big tick because it's just two rectangles on top of each other, a bit squinty. What about triangles though? Or what about other shapes? I mean, does it work for any shape? Well, let's have a wee think about that. So will it work for triangles? Would it work for circles or ovals? Or what about stars or pentagons? Does it work for them? Can we fit squares nicely into these shapes? I'm not so sure. Let's have a look. So hopefully you can all see what I've done here. I have drawn a triangle on a 1 centimetre square piece of paper. This is like the big pieces of A4 square paper that we have in the school, which are really good for area. I've then drawn a circle over here. I've drawn a blob, and I've drawn a pentagon, which is really a mixture of a rectangle and a triangle. So what I've done, let's look at the triangle first. What I've done for the triangle is I've put a 1 and a 2 and a 3 and a 4 and what squares are completely full of orange. Okay, because you can see that this one isn't completely full. There's a little bit off the side. There's a big chunk off the side of this one. There's a little chunk off the end of this one, a big chunk, a little chunk, a big chunk, and a little chunk. So these 4 squares here in the middle of it, they're okay, they're full squares. Then if you look at the circle, I've managed to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 full squares in there. And then there's a little chunk missing off this one. They're huge. You can just make out over here that these ones are just covered and no more, but there's big chunks missing off it. Small chunk missing up here and some other bits. Similarly for the pentagon down here, we've managed to get 10 full squares. And then these ones here, more interestingly, these are cut in half exactly down the middle because the line goes from the corner to the corner. And then over here in my blob, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 full squares. And then we've got some squares that have got a little bit of yellow in them, but are mostly white. We've got some squares that are mostly yellow and then a little bit of white. So we can't just ignore the fact that some of these have got colour in them and some of them don't. So we'll need to come up with a plan of how to count in the rest of this. What we do in this situation is we count the squares that have got half or more full of colour as full squares. So if I was to take let's say I take my green pen and I was to colour in half of this square, then I would say that we would take that up. That would be okay, we would count that as a square. But if I was just to colour in that much of that one, then that one's not really any use to us, is it? Because it's not really been taken up by all the colour. So what I'm going to do is I'm going to go around these shapes and I'm going to put a dot in every one that I think is more than half full. Okay, so on the triangles, that one's more than half full, that one's more than half full, that one's definitely more than half full, and that one's definitely more than half full. On the circle, this one's half full, that one's not, that one is, that one is, that one, no I don't think it is, but that one is. Okay, that one's not, these ones up the top, definitely not half full. These ones over here, definitely not half full. So I think those ones I'm happy with. If we go down to the blob, down at the bottom here, that's not half full, that's not half full, that's not more than half full. That one's mostly white, this one's definitely more than half full. These two little ones over here, they've just got a tiny little bit that's yellow, and this one here is definitely more than half full. That one's not, but this one definitely is. And then the ones around in the corner here, they're not more than half full. Now let's look lastly at the pentagon. These are all exactly half full, so I'm going to count these as a half, as a half, as a half, as a half. Okay, we'll come back to them in a minute. Let's look at the triangle, the blob, and the circle first. So for the triangle, we've got 4 that are definites, and then 4 that have got dots in them. So that means that we've got 4 plus 4 gives us an area of 8 square centimetres. For the circle, we've got 10 that we're really definite with. And then how many dots have we got? 1, 2, 3, 4. So it's 10 plus 4, and that gives us an area of 14 square centimetres. Remember the little 2. On the blob, we've definitely got 11. And then how many dots have we got? 1, 2, 3. So 11 plus 3 equals 14 square centimetres. That tells me that the blob and the circle actually take up more or less the same amount of area. Now let's think about this pentagon now. If we are sure, and in this case we are, if we look really closely at the lines here, that goes from that corner to that corner and this corner to that corner. So these are half full. So let's say that they're exactly half full. Let's call each one a half. Now the good thing about adding in halves is we know that 2 halves is 1 whole. So that means that we can do, we've definitely got 10 full ones, and then these 2 are a half. So if we add these 2, this one here and this one here, if we add these 2 halves together, then that's 1. So 10 plus 1, but we've got these 2 halves as well, so that's plus another 1. So 10 plus 1 equals 12 centimetres squared. Okay, so if they're halves, count them as halves, and remember that 2 halves make a whole. So if you have 3 halves, then you've got 1 1/2. If you've got 4 halves, you've got 2 wholes. Okay, we've covered a lot here this morning, a lot to remember. There's lots of more information in the tasks that I'm going to set for you this morning, but let's just remember what we've covered first, okay? We figured out what area means. It's the amount of space on the ground that a shape takes up. We measure area by breaking it down into smaller squares. We figure out how many small squares we can fit into the main shape. The unit of measure for area this morning anyway is in squares, so we've used square centimetres this morning. We went through some examples, and remember my top tip is I remember area by remembering that we measure it in squares, so I call it squarea. Then we talked also, we took it a little bit further, and we talked about how we measure the area of shape, like these. And remember, if a shape is more than half full, then we count it as 1. If it's less than half full, like these tiny little bits here, we just ignore them. And if it's exactly half full, we count it as a half. I hope this has helped, folks. There's lots of information in here, so remember to go back and look at little bits that you're not sure of and ask any questions that you need to. Thanks, folks.